quadratic functions, continue our discussion about quadratic functions, we mentioned that we can put them in the form of ax squared plus bx plus c equals 0, and that there are at least 3 different ways of trying to solve them, and one of them is factoring. So with this video, we want to talk a little bit about how we would factor things to solve it. And even within factoring, there's several different forms. The first one is the simple form where a equals 1. So in that case, we would just have x squared plus bx plus c equals 0. And so the general way we would get the answer to this, if a is 1, is that we would split this up into 2 factors, x plus m times x plus n equals 0. And I just created these variables to be any sort of number. And we'll talk about the properties of those as we go along. And so the key thing we could figure out, if we were to multiply this out using the FOIL method, if we multiply these 2 factors back together, we would get x squared plus m times x plus n times x plus m times n. And so we would see that this has to be the value of c, m times n, and that if we add these 2 numbers together, m plus n is the coefficient in front of b. And so the general rule is, for whatever we have, we need to find 2 factors of c that add up to equal to b. So, like I said, this generic rule works. If you have trouble thinking about things in terms of positive and negative, when you think of factors of c, one thing you can do is split these up into different cases. One is for any time c is greater than 0, and another is for c is less than 0. But then even with those, we would split it up into what does b look like. So we really end up with 4 different cases, which is c is greater than 0 and b is greater than 0. C is positive and b is negative. C is negative, b is positive, or both c and b are negative. And so each one of those have slightly different things we can think about with regards to this that will help us in regards to determining m and n. If we have both are positive, we can really just think of this as the base case without having to, and we don't need to make any sort of simplifications. We're going to have x plus something and x plus something else is the way that we would get that final, where both m and n are greater than 0. And just to sort of clarify, the reason we're having different cases here is if we're assuming m and n are both positive, we're adjusting the signs within the factors to do this. So if both c and b are positive, both m and n have positives there. If c is positive, but the b is negative, well then that means we must have subtracted both m and n, because multiplied together we would get a positive number, m times n, and we would have minus mx and plus minus n times x. So to get a negative term in the middle, it's still going to be the same sort of factors that multiply together to get c, to get the absolute value of c, really. But the middle term will add together to get the absolute value of b. We'd have subtraction there. For the cases where we have a negative value of c, that means the signs must be opposite within here. We must have either we must have one of them is plus and one of them is minus, and over here one of them is minus and one of them is plus. The convention that I've taken here, and so really all that tells you is the sign of b will tell you which the bigger one is with the plus. So if b is positive, the bigger one, which I've said that m is bigger than n, is with the plus sign. If it's negative, then that must mean the bigger one, m, is with the negative sign. And so that's how we can solve it. And then let's just see some quick examples of how that would work for each case. Okay, so this example, we'll say that we have x squared plus 5x plus 6 equals 0. So that's in the category of both c and b being positive. So I know that it's going to be x plus something times x plus something. So what I need to figure out are factors of 6 that add together to get 5. So if I look at that, factors of 6 are either 1 and 6 or 2 and 3. If I try adding them together, add 1 and 6, I get 7. Add 2 and 3, I get 5. So these are the ones I want. So x plus 2 times x plus 3 equals 0. And that's factoring it, but remember I also am trying to solve a problem here. And so the way I solve the problem is to remember that in order for this to be 0, one of these two factors has to equal 0. And so if I set each of those equal to 0, x plus 2 equals 0, or x plus 3 equals 0, I subtract 2 from this side, I get that either x equals negative 2 or x equals negative 3. And that's how I would solve one where both coefficients are positive. Alright, so let's look at an example where c is positive, but the b coefficient is negative. So I've got x squared minus 8x plus 12 equals 0. Again, for that case, I know that I'm going to have x minus something and x minus something else is going to equal 0. The key point to that being, again, that when I multiply them together, I have to get 12, but when I add them together, I'm going to have to get 8. So let's think of the factors of 12. So if I think of the different ways I can factor 12, I can have 1 times 12, that adds to 13. 2 times 6 adds to 8, which should be the one that I want. And then the other combination is 3 times 4, which adds to 7, so that is not the one I want. So my factors are x minus 2 and x minus 6 equals 0. And then again, that's just the factors to get the solutions. I would have to set each part equal to 0, so x minus 2 equals 0, or x minus 6 equals 0. So x is going to equal 2 or 6. So 2 possible solutions there. Okay, so if we look at another example where here we're looking where c is a negative number, I've used negative 24 here, and b is a positive number, I've used positive 5 here, equals 0. I can split that into 2 factors. And so I split into 2 factors. I know one of them is positive and one of them is negative. And in this case, I know that the bigger one has to be positive. So when I'm thinking of factors of 24, this time I'm going to put the bigger number first as m and the smaller number second as n. The other thing to keep in mind is, as I split that really, remember, I'm subtracting this second factor n from it. So for each one of these, I've got 24 and 1. If I had a positive 24 and a negative 1 there, I would get a positive 23 in the middle. That's not what I want. The one that's going to get me the 5, like I like, is 8 and 3. So my factors are x plus 8 and x minus 3. And now that I've worked a few of these, so my factors are x plus 8 and x minus 3 have to equal 0. And now that I've worked a few of these, I know without drawing in this extra step in between that x is just going to be the opposite of this. So that's going to give me a value of negative 8, and that one's going to give me a value of positive 3. All right, now for another example, where this time where c is negative and b is negative. And actually I have to make it an odd one just to make sure. I have been trying to make them more complex with more factors that have gone along. But the other thing I want to show is that, not everything, you're not always going to have an even number on the end. You can't have odd numbers. So I need to find factors that are x minus the bigger number and x plus the smaller number are going to equal 0. So again, as I write out my factors, I'll do them kind of backwards. Alright, so as I do my factors, again, they have to multiply together to be 105. They have to have a difference of 8. So 105 and 1, way too big. 35 and 3, way too big. 21 and 5, getting closer. It actually turns out the last one I tried, 15 and 7, we get a value of 8 is the difference. So again, and I know that the negative has to go with the bigger one because I have a bigger thing there. So it's x minus 15 times x plus 7 equals 0. So x is equal to 15 or negative 7. The key thing I do want you to realize is that all of these different ones, I've kind of made it more complex than it need to be, are really just the original one we talked about, where still m times n equals c. It's just a matter of like trying to take out the different negatives. In reality, you just may factor a negative. In other words, if we look at this a different way, an alternate view is, if I took that last example, x squared minus 8x minus 105 equals 0, I could really just look at the factors, but just make sure that m times n is negative 105, and that m plus n is negative 8. So the alternative way to look at that is I can have factors of 1 and negative 105, which add to negative 104, or I can have a factor of negative 1 and positive 105, which add to positive 104. And of course, obviously, I wouldn't need to check all of these until I got close, and then I could just worry about getting the right sign. So I could do 3 and 35, or I'm sorry, 3 and negative 35, which gets me negative 32. I can do 5 and negative 21, which gets me negative 16. And of course, I already got into the last one, which is 7 times negative 15, which gets me negative 8. I also can keep going and do negative 7 times positive 15, but that gets me plus 8. And so the one I want is with it being negative 8. So if I really think about that as just being m and n, then my factors are x plus 7 and x plus a negative 15, which is minus 15. So either way I look at that, it's the same way, equals 0, and end up with the same solution, negative 7 and positive 15. So hopefully that will help you in terms of understanding factoring when the leading coefficient is 1.